Imagine a world without a calendar, a world where the past is a blur. This was, well, the reality for much of human history. We had only vague estimates of when ancient civilizations rose and fell. The invention of radiocarbon dating in the 1940s changed everything. Developed by Willard Libby, this revolutionary technique gave us a time machine. It allowed scientists to accurately date organic materials from the distant past. Radiocarbon dating transformed our understanding of archaeology and many other fields. Before radiocarbon dating, archaeologists relied on stratigraphy. This method involved studying the layers of soil in which artifacts were found. It was an imprecise way to determine age. Radiocarbon dating provided a much-needed tool for accurate dating. It opened new avenues for understanding our past. Radiocarbon dating relies on a fascinating cosmic phenomenon. High-energy particles called cosmic rays constantly bombard Earth's atmosphere. These cosmic rays collide with atoms in the atmosphere, creating a cascade of secondary particles. One of these particles is a neutron. When a neutron collides with a nitrogen-14 atom, it transforms into carbon-14. Carbon-14 is a radioactive isotope of carbon. It's unstable and slowly decays over time. This process of carbon-14 creation is continuous. It maintains a relatively constant concentration of carbon-14 in the atmosphere. Living organisms constantly absorb carbon-14 from the atmosphere and food they consume. This absorption stops when an organism dies. Carbon-14 is radioactive, meaning its nucleus decays over time. It emits a beta particle and transforms back into nitrogen-14. This decay happens at a predictable rate. The half-life of carbon-14 is about 5,730 years. This means that after 5,730 years, half of the carbon-14 in a sample will have decayed. After another 5,730 years, half of the remaining carbon-14 will have decayed, and so on. Scientists can measure the remaining amount of carbon-14 in a sample. By comparing it to the initial amount, they can calculate how long ago the organism died. This method provides a reliable way to date organic materials up to around 50,000 years old. While the principle of radiocarbon dating is straightforward, there are factors that can affect its accuracy. One important factor is that the concentration of carbon-14 in the atmosphere has not always been constant. Variations in solar activity and Earth's magnetic field can influence the production of carbon-14. To account for these variations, scientists use calibration curves. These curves are generated by comparing radiocarbon dates with dates obtained from other independent dating methods. Tree rings are particularly useful for calibration. Trees add a new ring each year, and these rings record the atmospheric carbon-14 concentration at the time of their formation. By analyzing the carbon-14 in tree rings of known ages, scientists can create calibration curves that extend back thousands of years. Section 5. Accelerator mass spectrometry, a new era of precision. Early radiocarbon dating methods required large samples. This limited the types of artifacts that could be dated. The development of accelerator mass spectrometry, or AMS, in the 1980s revolutionized the field. AMS allows scientists to measure carbon-14 in much smaller samples with greater precision. This has opened up a world of possibilities for dating previously inaccessible materials. Artifacts as small as a single seed or a fragment of bone can now be dated. AMS works by accelerating ions to incredibly high speeds and separating them based on their mass-to-charge ratio. This allows for the direct counting of carbon-14 atoms, even in minuscule samples. AMS dating has significantly expanded the applications of radiocarbon dating across various disciplines. Section 6. Rewriting history, radiocarbon dating in archaeology. Radiocarbon dating has had a profound impact on archaeology, revolutionizing our understanding of the past. It has provided accurate dates for key events in human history, from the emergence of agriculture to the rise and fall of civilizations. One of the most significant contributions of radiocarbon dating has been in understanding the peopling of the Americas. Prior to radiocarbon dating, there was much debate about when and how humans first arrived in the Americas. Radiocarbon dating of archaeological sites across North and South America has provided compelling evidence that humans arrived in the Americas at least 15,000 years ago, and possibly earlier. This has significantly pushed back the timeline for human presence in the Americas and has helped to reconstruct the migration routes of early humans. Section 7. Unearthing the secrets of ancient civilizations. Radiocarbon dating has been instrumental in unraveling the mysteries of ancient civilizations around the world. It has helped to establish chronologies for these civilizations, track trade routes, and understand cultural interactions. In Egypt, radiocarbon dating has been used to date tombs, mummies, and artifacts, providing a more accurate timeline for Egyptian history. It has also shed light on the trade networks that connected Egypt with other parts of the ancient world. In the Americas, radiocarbon dating has been used to date Mayan temples, Aztec artifacts, and Inca settlements. This has helped to reconstruct the history of these civilizations and understand their interactions with each other. Section 8. Plumbing the depths radiocarbon dating in oceanography. Radiocarbon dating is not limited to terrestrial applications. It also plays a crucial role in oceanography, helping scientists understand the age, circulation patterns, and biological productivity of the world's oceans. By analyzing the carbon-14 content of seawater, marine organisms, and sediments, oceanographers can track ocean currents, study past climate change, and understand the cycling of carbon in the ocean. Radiocarbon dating of deep-sea sediments has provided valuable insights into the history of Earth's climate. It has revealed past changes in ocean circulation, temperature, and carbon dioxide levels, helping scientists understand the natural variability of Earth's climate system. Section 9. Deciphering Earth's climate history. Radiocarbon dating is a powerful tool for reconstructing Earth's past climate. By analyzing the carbon-14 content of various archives, such as ice cores, tree rings, and ocean sediments, scientists can reconstruct past variations in atmospheric carbon dioxide concentrations and temperature. These reconstructions provide a long-term perspective on Earth's climate system, helping us understand the natural cycles of climate change and the factors that have influenced Earth's climate over time. Radiocarbon dating has played a key role in understanding the relationship between carbon dioxide levels and global temperature. It has shown that periods of high carbon dioxide concentration in the atmosphere are generally associated with warmer temperatures. Section 10. Beyond the past. Radiocarbon dating in the modern world. While radiocarbon dating is most commonly associated with studying the past, it also has important applications in the modern world. It is used in a variety of fields, including forensics, art authentication, and environmental science. In forensics, radiocarbon dating can be used to determine the age of human remains, helping to solve crimes and identify missing persons. It can also be used to date materials found at crime scenes, such as clothing or weapons. In art authentication, radiocarbon dating can be used to determine the age of paintings, sculptures, and other artworks. This helps to distinguish genuine artifacts from forgeries. Section 11. A legacy of discovery. Radiocarbon dating's enduring impact. Since its invention, radiocarbon dating has revolutionized our understanding of the past and continues to shape our knowledge of the world around us. It has provided a powerful tool for scientists across various disciplines, enabling them to unlock the secrets of time and gain new insights into human history, the natural world, and our place in the universe. From archaeology to oceanography, climate science to forensics, radiocarbon dating has left an indelible mark on scientific inquiry. As technology continues to advance, we can expect even more innovative applications of this remarkable technique, further illuminating the mysteries of our planet and beyond. The ability to accurately date objects from the past has fundamentally changed our relationship with time. It has given us a deeper appreciation for the vastness of history and the interconnectedness of life on Earth. Radiocarbon dating stands as a testament to human ingenuity and our unquenchable thirst for knowledge.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.